So in test tube number 1, I have chlorine water. This is just bleach in water. And then I have bromine water, which is bromine put into water. It does color the water a little bit, so we know that there is some bromine in there. Now, in order to get the chlorine diatomic molecule to develop in test tube number 1, I'm going to add a few drops of sulfuric acid. Just a few drops. And this will be what sort of activates the development of chlorine in water. So one of the ways we know that this is working is that there's a distinct pool smell, right? The chlorine that they use to sterilize pools. Okay, so this is just chlorine and bromine in water. What I'm going to do now is put some cyclohexane in there. And once I get cyclohexane in, the cyclohexane is going to draw that neutral molecule into it. The reason we want to do this is to get an idea of what we should see if bromine is in our halogen layer, or if chlorine goes into our organic layer, which is the cyclohexane. So again, just to kind of give a better visual, this is the chlorine bleach solution. It has had some acid added to it. And then the bromine water. So I'll bring a little background into it to make it easier to see and focus. So that's the bromine water. Now I'm going to add the cyclohexane, and we'll be able to see what happens when a halogen goes into cyclohexane, what it is we're supposed to be looking for when chlorine or bromine goes into those layers. Now I'm going to be adding more than what your procedures call for, just because we want to make sure that we can really see this well. So I'm going to use a little bit extra. So if I just do this and don't actually mix it, the only way the halogen is going to be able to transfer into my cyclohexane is at the surface. Notice that this is 2 distinct layers. Maybe hard to see against a white background, but let me erase some of the markings on here. So I've erased some of the markings on test tube number 1 to make it a little bit easier to see that double layer. Both these solutions are relatively clear, so it's going to be tricky to see that second layer. I'll try it with my glove, since it's flat. It'll be easier to see. So there's a second layer. There's 2 layers in this test tube. I'm going to shake this pretty vigorously, to try and get some good mixing to occur between these 2 layers. Because if I don't mix it, the only contact the halogen is going to have with the cyclohexane is at the surface between the water and the cyclohexane. So I'm trying to mix that up really well. Classic flicking technique. Trying to mix this up really well so that they separate. So again, we'll put a white background behind it. See if you can observe any difference in color. Now, one of the questions I get many times is, what is the top layer and what's the bottom layer? And it has to do with the density of the 2 liquids. the less dense a liquid is, and if they're immiscible, like cyclohexane and water are, the less dense material will go on top. So cyclohexane is less dense than water. That's why cyclohexane is always going to be your top layer here. So that is the cyclohexane with the chlorine pulled up into it. Now we'll do the same with the bromine. And again, notice that the bromine is starting to go into our top layer, but without some added kinetic energy, we're not really going to see much transfer. So I'm going to go ahead and mix this. Again, the top layer is your cyclohexane. So we can see now a pretty big difference. Again, I'm going to erase the markings on here to make it a little bit easier to see the colors, so that you can see that there is indeed a very big difference once the bromine goes into the cyclohexane. Initially, the cyclohexane is clear, colorless, and floating on top of the aqueous layer, and then once it absorbs a halogen, it will take on a specific color to that halogen. One last time, here is the bromine in cyclohexane. Again, the cyclohexane is the top layer. We know it's only bromine in here because only bromine was present in that aqueous layer. Okay, now we are continuing with our next set of test tubes, and in this set we are going to see if chlorine is able to displace bromine and or iodine. So in test tube number 3, I have aqueous sodium bromide, and in test tube number 4, I have aqueous sodium iodide. These are the halide forms of bromine and iodine. Now, since they are halides, if I add cyclohexane to these test tubes, and I mix and I mix and I mix, we're not going to get any halogen in there because there is no halogen present, only halides, right? We know from our background information and from the observations that we've just taken with the bromine that if bromine were present in this test tube, this cyclohexane would be turning bright orange, right? So if there was bromine present, we would be seeing an orange color. If there was iodine present, based off of the background information that we've been given, the top layer would be turning a pinkish purple. So what we're going to do now is add chlorine. So chlorine in the bleach form. So I'm going to add a milliliter or 2 of chlorine water to each of these solutions. And we don't even need the acid really to already start seeing something take place with the iodine. But for good measure, we're going to go ahead and add a couple drops of acid. Again, this is to get the bleach to release chlorine gas. So test tube number 3 currently has, what we've added to test tube number 3 is chlorine, diatomic chlorine, and bromide. Those are the 2 halogens in there initially and in what forms they are. We are going to see if chlorine gets pulled into the cyclohexane or if bromine gets pulled into the cyclohexane, meaning that a redox reaction would have taken place. So in order for there to be bromine present, the chlorine must be displacing the bromine. So based off of the color, after we mix this really well, based off of the color of our cyclohexane, we'll be able to tell what halogen is present. And based off of what halogen is present, we'll be able to know if a reaction is taking place. Again, remember, the top layer is your cyclohexane layer. This is the sodium bromide with the chlorine added to it. The cyclohexane is pulling whatever halogen is present in this test tube up into it. In test tube number 4, we've added sodium iodide, chlorine, and cyclohexane. Again, the cyclohexane is going to draw whatever halogen is present up into the test tube. Okay. So after some vigorous shaking, we are letting the 2 layers gradually settle out of solution. Then your top layer is the cyclohexane layer. So does the cyclohexane have chlorine or iodine in it? And based off of that, we'll be able to tell if a reaction took place. Remember, we started with iodide and chlorine. Okay, now we'll move on to the next set. Okay, we are in our last set of test tubes for our halogen redox reactions. So in this final set of test tubes, we are checking to see if bromine is able to displace chlorine or iodine. So if bromine is able to displace the chloride ion from solution, or if it's able to displace the iodide ion from solution. In test tube number 5, I have aqueous sodium chloride, and in test tube number 6, I again have aqueous sodium iodide. Okay, so sodium chloride, sodium iodide. Again, these are the halide forms, the ones that have ions. So if, again, I add cyclohexane, because there's no halogen present, there's nothing there to color the cyclohexane layer. So without a neutral halogen present, nothing goes into our cyclohexane layer. It stays empty, which is why it remains colorless currently. So we haven't added the bromine yet. Let's go ahead and do that and see what happens. Again, this is a little bit of bromine dissolved in water. It does have a pretty strong odor to it, so it's always good to handle this under ventilation. So I'm adding about a milliliter or 2 of the bromine water. And we'll see if the cyclohexane is drawing up bromine, chlorine, or iodine. Okay, so again, I'm going to shake these test tubes up. We have to think about, if a reaction takes place, what will be the neutral halogen in solution? If a reaction does not take place, then the original halogen we put in is going to be in solution. The way we tell, again, is by seeing what halogen goes into our cyclohexane layer. So, Here we go, test tube number 5, where we've added bromine water to our sodium chloride. Has the cyclohexane layer drawn up bromine or chlorine? And use that to decide whether a reaction has taken place or not. Again, I'm going to mix, this time test tube number 6. Pretty good. Again, we're going to use our observations to decide what has gone into solution. Have we put bromine or iodine into the cyclohexane based off of the color that we observed? And based off of that, we can then decide if a reaction has taken place or not. Trying to get some good visual on the color for the top layer. You can kind of tell a little bit of the light going through. What is the color of your top layer? And that is telling you what halogen is present. Okay. All right, so that is the experiment involving redox with halogens. Again, we're using the color of our cyclohexane layer to decide what has been either left in solution as a neutral halogen or what has been produced as part of a redox reaction as a neutral halogen. And don't forget, guys, when you clean up, anything that has cyclohexane in it needs to go into, right? Anything with cyclohexane in it needs to go into a separate waste container. Never put cyclohexane into the aqueous waste containers because it'll separate out. We also, because everything has halogens in it, need to put this in yet another specialized waste container, one for halogens specifically. So we have to be very mindful of where we put our waste when we're working with organic solvents and especially when we're working with halides.